Hello everybody, and welcome to a brand new tutorial. Today we're gonna do a tutorial on game development, and we're gonna try to make a game in less than 1 hour. So let's go ahead and create our project without further ado. So we're gonna name it project name. Okay, we're gonna make tower defense. So okay, what else? Location, it's gonna be squadron IA shooter tests. We're gonna put it inside. I'm gonna make a new folder for the tutorials. Okay, so we're gonna name it tutorials. Alright, I'm gonna name this the folder. What's the name? Tower defense. Okay, let me first. Alright, so we're gonna select this. Alright, and create 3D game. So we're gonna give Unity a couple of minutes to create the whole thing. It shouldn't take much, not except for that. Oh, this is another project, so I'm gonna close that. And here we are in new scene with a brand new project. So we're gonna create our folders. First folder, I'm gonna name it scene. Okay, and obviously another folder with the name prefab. You're gonna need prefabs. I don't know if it's prefab or prefabs. Anyway, so we're gonna save this scene. Oh, not save project, actually save scene. Save scene as excuse me, inside scenes. I'm gonna put the name main. Alright, and we're gonna save. Great. So first step, we're gonna create a plan. Or a cube, it depends. We're gonna create a cube to use as our terrain and in the z-axis 100 unit. Alright, it has already a box collider, so this is our cube. We may give it a different color. Come on, we should give it a material. So create folder, materials. Okay, we're gonna create new material, terrain. Alright, we're gonna give it a greenish dark color. So this is our terrain. Alright, and we're gonna create couple of enemies and turrets. Okay, we're gonna rename this to terrain. This is gonna be a pretty forward tutorial, so it will actually, I will not make any special assets for this game, so I'm gonna use mostly cubes and spheres. So it's just to see how we make tower defense games, nothing more. If you wanna make it, if you want a more polished game, you should use your own assets, but you can pretty much do whatever I do in here with your own assets, so it won't be that hard. Alright, and so this is a cube. We're gonna make it a little bit smaller, so maybe 3 by 3. Okay, this is a cube. Okay, so this is gonna be a tower. we're gonna name it tower. All right, and maybe we're gonna add another cube in here. All right, a smaller one. Okay, so this is our tower. All right, this is the turret of the tower, and maybe we're gonna add capsule cylinder. Maybe we're gonna use a cylinder, who knows. I don't know if this is too much or not, but we're gonna try. All right, so this is a tower. All right, I see. Anyway, we're gonna leave it that way. So as I said, we should finish this in 1 hour, so I'm gonna make the most of it. So this is a tower. This is tower 1. We're gonna name it tower 1. We're gonna create a material for it. This is gonna be not the most dangerous tower, so we're gonna give it a lighter color. So maybe tower 1, and you're gonna give it the reddish color, maybe. All right, okay, all the element of the tower 1 and the cube and the turret. Okay, so this is tower 1, and we're gonna duplicate this one, Control D or Command D if you're on Mac, and we're gonna name this tower 2. We give it another material. We're gonna duplicate this material. It's already with the 2 number, and we're gonna give it a darkish color. This is an evil tower. All right, we're pretty much done with our towers. So I think 2 towers, maybe 3 towers. 3 towers gonna be amazing. 3 towers will be a great variety of towers. So this is the 3rd tower, and we're gonna duplicate the color one more time, and this gonna be the easiest tower, I believe. Yeah, so this should have a bluish color. Why not? All right, so we're done with the towers. All right, 3 towers. Now we're gonna create our enemies moving through the towers. Now, before creating the enemies, we should make some system for the path. So let me think how we can make this. We need to create a path. So yeah, maybe an array of object, that would be amazing. So we're gonna create empty, name this path with capital P, and we're gonna create a lot of cube children. All right, F so we're gonna duplicate this one. Maybe they will instantiate at this point and start moving forward. Cube 1, Control D, cube 2, this should be cube 0, okay, cube 2, Control D, cube 3, and Control D, cube 4, Control D. What I have done, so 0. Alright, cube 5, Control D, cube 6. I'm gonna make it a little bit interesting path for the towers, so this shouldn't take much time. Control D. Alright, Control D. Alright, Control D. Alright, Control D. Alright, Control D. And we're still going forward. Control D. Alright, we need to make it a little bit interesting. Alright, we're gonna close the loop, right? So they can so we can see them go forward. Oh, I just don't see the 2 elements in here. It's okay, we can fix that. I know this seems a little bit dull, but certain point there will be action in here, so bear with me. Okay, and we're done. Okay, so we have our path. Okay, we can place our towers anywhere we want, and I'm gonna take for instance this tower 3 and move it a little bit in here, so we give it a maximum range along the path. And tower 2 will be in here. This would be awesome. And maybe tower 3, actually this tower 1, oh I see now, this tower 1, so we're gonna put tower 1 in here. Actually it doesn't matter, Control Z, we're gonna move tower 1 in here, why not? Okay, alright, so Control S to save our scene, and we're done with the design. Now what we need is an enemy. Our enemy gonna be a capsule, maybe a couple of capsules, yeah, I think so. So let's go ahead and make another empty object and name it enemies. Alright, so this enemy gonna have multitude of capsules, so we're gonna go with capsule 1. It should have a material, so I'm gonna go with we're gonna name this enemy. Alright, and we're gonna give it some color. What color should the enemy have? Yellowish color maybe? Yeah, yellowish color, maybe yellowish color. Okay, so this is our capsule, and here it is. Okay, so we're gonna move it in here at the start of the path. Alright, so how many enemies we're gonna put? Let's see. For now we're gonna create 1 enemy. And okay, so what do we have? We have path, enemy, and tower. I can see 3 simple classes in here, so we're gonna go ahead and create new folder, name it scripts, and start our first class. Create C# class, and we're gonna name it, let's see, let's name it tower or enemy. Let's name it enemy. Okay, let's start with the enemy. Okay, enemy. Okay, we wait for I think it's Visual Studio. Alright, we wait for Visual Studio Community Edition, and I don't think if I should or shouldn't. Let's see, what's the screen? Okay, this is the second screen. Okay, if I'm gonna need to put the Visual Studio on the other side, so I'm gonna scroll between the 2 screens so you can see what's going on. Okay, alright, so yeah, I go back to my enemy class, and in here guys we're gonna put some basic things. Okay, we already went 15 minutes, so we should pick up because we don't have time. Okay, so what we're gonna do, enemy, what an enemy need? The enemy should get the path. First of all, an enemy gonna have a public we don't care about if it's private or public. We're gonna put all the fields public, so we can see the values in real time. So that's the whole point. Otherwise this is public, and it's gonna be a float speed. All right, and what else? There is a speed, and we're gonna need a public and game object, maybe. I think game object, and we're gonna name this path. Okay, we're gonna put the we're gonna link the path in here. And what else? Okay, let me put this on. Actually, we even either we make this class general enemy manager, or we do make this class for each enemy. So I think I'm gonna go with the first approach. We make it a general enemy manager or a simple enemy. Okay, let's start with the simple enemy for now. Okay, speed path. I get the path. I don't know why I should get the path. Actually, I'm gonna get, if I am a single enemy, I don't need to know the whole path. I need just my next transform to move to. Or we can calculate this on our in our class. So all right, so I'm gonna start with the first method, void find get the path. Void get the path. All right, and void get the path, we're gonna look for path. If we're gonna make simple test, if path equal null, then path equal game object dot find, and we're gonna give it a name, find what I call path. So in here it should be a string. So we get our path, and this is get the path. We're gonna start this I think on the awake. It's better in a way. So we're gonna call get path in here. It's always a good practice to encapsulate everything in functions. So get the path, and we were gonna get the path. What else? So what else? So we're gonna move through the path. Now either we're gonna start moving in the path straight forward as soon as, okay, so we're gonna start with we're gonna get the path. After an instantiation, an enemy gonna get the path, and then gonna look where to move. So we're gonna move through the path. Well, navigate path. Okay, navigate path, and this should be straightforward also. For the navigate path, this is gonna be very easy unless we don't know where we are on the terrain. So oh, you don't have my my beautiful picture in there, so I'm gonna put it back. This won't take much time, guys. Video capture device, I think, and add existing video capture device. All right, tic tac. That was easy. That didn't take any time. All right, we're done. Getting back to our navigate path. So for navigate path, we're gonna have each enemy gonna have an array, public array or list, whatever you want. We're gonna go with list of transforms. All right, and come on, list of transforms. We're gonna name it nodes, maybe, right? That's it, and it's a node. So in navigate path we're gonna fill this node list. And so what we're gonna do, we're gonna start with nodes equal a brand new node list of transformers. And so we have our new list. Now what we're gonna do, we're gonna make a for each let's name it node in where, in path. We do have the game object that contain all the transformers of the nodes, right in here, right in here, right in here, right in here. This path element has all the cubes that construct our path. Okay, so getting back, and as I said, var node in path dot get all the, well, not in children, I think, yeah, get components in children. All right, and then we're gonna give it transform, and we're done. So we're gonna look for each transform in the children, and then we're gonna add it, nodes dot add the node, right? All right. Now we have our, no, this is not a navigate per se, but it's more of a populate function. So either we're gonna refactor this to void populate path, and we're gonna go ahead and take this and put it in here, right? And then inside navigate path we're gonna call first populate path. Straightforward, guys. Populate path. Then what we're gonna do, so we populated the path. What now? Well, after a successful population of our path, we're gonna look for the closest node, right? So we're gonna make another function void get closest node. And how this gonna work? Oh, come on. Get closest node. So get closest node will look through the nodes and calculate the distance between the game object, the enemy, and the node, the transform of the enemy and the transform of the node. So we're gonna start with for each. Yeah, it's a for each because we have a list of nodes. So for each var node, this is gonna be a node, a local variable in nodes, right? Or this dot nodes, this mean absolutely the same. All right, so for each var node in this dot nodes, we gonna I see. We're gonna look for the closest okay, let me think how we're gonna do that. We're gonna just pick the closest distance. We should calculate the distance. Let me think about this problem. So if we are in here and we want to go to this point, we're gonna calculate the distance. Okay, so I'm gonna try this. For each var node in this dot node, var distance equal vector 3 dot distance, and we give it the vector 3 a and b. So the a gonna be this dot transform, this dot transform, and node dot position. Of course this should be dot position. All right, and node dot position, and we have the distance for each node. Now we need to give best distance. We're gonna put it best var best dist or dist equal math dot infinity. This is our best distance for now, and we're gonna compare it with the distance. Now I think the distance will be always an absolute value, return the distance between a and b. So as far as I remember, so I'm gonna go with if best dist superior than distance, then our best dist will equal distance. Easy peasy lemon squeezy. All right, and get closest node. So this should return something normally if we're gonna get. So this should return the transform. What? So this should return one of what? Yeah, I meant you should return transform and get close nodes, and this should return a transform. So we're gonna go with transform. Why am I okay? Transform, and we're gonna name it tron equal for now null, or the first element in the node. We can do both. We can do both. We can do both, guys. Okay, we're gonna go with the first element of the node. It's the easiest way. So this dot node, and the index of the item is gonna be the first item. So, and then in the end we're gonna return the tron, which is the closest transform in the node list. And in here, if the best distance is superior than the distance, then the best distance will take the distance, and that becomes the cup, and that becomes the best distance. And the tron will take the node dot node. Actually, no, tron will just take the node. Okay, that's it for each item. If only our saved value is still bigger than the remaining values. That's it. This is done. So we're gonna at the end we're gonna return the transform, and the transform will always be a transform. So this is a private method. We can put it right there. And as I said, we will always return a transform whatever the situation is. If there is no close value, then we absolutely gonna start with the first node, and if actually there is a closest item to our then we're gonna return the closest transform, okay, to our enemy. We're gonna return the closest transform. So now what we gonna do now, this is populate path and then get closest node. So we're gonna create I see. Okay, so var trans equal get closest node. Okay, this is gonna be transform. Var it's a notation that means you should use the you're telling the C# use the type inference to guess the type, and if our function returns a transform, then this var the compiler gonna read it a transform. If it returns a string, the compiler gonna read it a string. See, so it's just all right, you get the point. Now we populated path, we got the closest node. What else? How much time oh my god, we already made, oh I don't think this gonna, okay, so the what else? Think. Populate, get the closest node. Now we have to move to the node, so we're gonna go ahead and create another function, void, and move to node, right? Okay, and so how this gonna work? Move to node will actually take a parameter called of type transform and called trans, not transgender, just transform, and we're gonna use this node to move towards it. So my point is transform dot translate. Oh, actually I think it's in the, let's say, game object, yeah, dot transform dot translate, yeah, I see it, translate. Okay, so we're gonna give it a vector3 translation. We're gonna test in a couple of seconds just the enemy, how the enemy is doing in the path. So we're gonna just finish this, void transform to translate, and then we're gonna give it a vector3, our trans dot position. That's it. Actually we could use our speed, but for now let's see, right? Okay, let's move back to the other screen, and oh, we should put this enemy on our capsule. Come on. Oh, we didn't call move to node. Sorry. We're gonna call move to node on this object, or easily either we're gonna do move to node and we're gonna give it the whole thing, get the closest, right? This is still true, or we keep a reference to the transform. I don't think we're gonna need this. Yeah, I don't think we're gonna need to keep. We should keep. It doesn't matter for now. Okay, so this is it. Move to node and get closest node. We return our transform, and then we're gonna move towards there. So let's see how this is doing inside Unity. Now, this is our enemy class. We're gonna put it in here, and let's leave it in there. Okay. So technically, navigate path. Let me get back to before we start anything. Navigate to path. Where is navigate to path? Navigate path, yeah. We're gonna start with get the path in the awake, okay, and then populate path, and then navigate path. We'll populate path and then move to path. Okay, so we're gonna call navigate path in the awake or in the start. It doesn't matter actually. So I'm gonna just call it in the start to be, because awake starts first. It's the first function to be executed. Actually, there is other functions that executes before awake, but in the hierarchy, awake goes before start and then start. So I'm gonna go with a start to be sure that the enemy got the path. So getting back to our Unity and hitting, come on dude, come on. Okay, capsule. We do have our enemy class and the path, the nodes, the speed. Okay, we don't use speed for now, remember, but we're gonna use that pretty soon. Let's see. Okay, what's going on? Oh, we have a null reference. The enemy, the 35 line. Okay, I think where this will take us. Valve to get components in children transform. Components in children transform. Because he didn't find the path. Maybe. If path equal null, path equal game object that find path. Finds the game object by name and return it. So let me see game object path. Okay, we're gonna assign for now publicly, but I'm gonna look into it because we need to see what's wrong with it. Okay, so I assigned the path and I hit start. What? Is there something I'm not getting it? Give me a second, guys. Play. What the fuck happened? Object reference not set on it. Are you fucking kidding me? Game object that one. Yeah. Maybe as game object? I don't know. Game object. Come on! As a game object? Maybe this is the reason? Come on, dude. Seriously? Okay, let's see. Find is not working. I don't know why. So get the path. If path equal null and path is equal null. Find game object with tag. Find object of type. Find. Okay, we can use tag. Let's try with find game object with tag. And we're gonna give the tag path. Okay, so getting back to our code, this is what I changed. Path equal game object find game with tag, and then the tag gonna be path as game object. Now I'm gonna see if this is the problem in here. So we're gonna give it a tag. Come on, give me a tag. Add a tag, and we're gonna go in here and name it path. Thank you. We're gonna save. We're gonna clear this. We're gonna hit our capsule and click play to see if the path still in there. What the fuck is wrong? Line 35. Something is very wrong. Line 35. For each var node in path dot get components. Okay, our path is a game object. It has transform as children. I should get you back to the other screen. So path dot get components. Get components in children. Guys, excuse me for a second. So I need to take this. Actually, I will ignore it. So let's see, something is very wrong. Okay, I'm gonna stop this.